Alright, so the second section or second part of P7 is going to be solving equations. Really, we're going to focus on this whole one about quadratic equations because there's several different ways we're going to solve them. Okay, so the four ways we're going to solve them: one is by factoring in the zero product principle, which we've done a ton of factoring already. We'll talk about the square root principle, completing the square, which will tend to be the most difficult for us, and then finally the quadratic formula, which is the easiest part for it. So if we talk about factoring and the zero product property, here we start by factoring. So we're going to take out a 2x, which would leave us with a 2x minus 1 on the inside. And what the zero product property says then is that we can split these two factors, because if either one of those is equal to 0, then 0 times anything else will be good. So we're going to have 2x equals 0 or 2x minus 1 equals 0. Solving, we get x equals 0 for that one. We add 1 to both sides, divide by 2, and we get x is equal to 0.5 for that one. Okay, so factoring, you're going to take out your greatest common factor, and then the zero product property says to set each factor equal to 0. And then we solve. Okay, on ones like this, when it's not equal to 0 already, we have to subtract 4 from both sides so that we can set it equal to 0. And now we're going to factor our trinomial according to the way we've done it before. So no greatest common factor, 2x squared, I'm going to say this is going to be plus 8x and minus 1x minus 4 equals 0. And I got those two numbers because 2 times negative 4 is negative 8. Factors of negative 8 are 8 and negative 1, and 8 and negative 1 add up to 7. So if I do my factor by grouping here with a plus in there, I can factor out a 2x from the first one, which is going to give me x plus 4. I can factor out a negative 1 from the second one, which again is going to give me x plus 4. And so I end up with 2x minus 1 and x plus 4 equals to 0. And now I'm going to do my zero product property. So 2x minus 1 equals 0 or x plus 4 equals 0. Adding 1 to both sides, dividing by 2, I end up with x equals 0.5 again, or subtracting 4 from both sides, I end up with x equals negative 4. Okay, so that is the zero product property, and factoring, the biggest thing there is we set each factor equal to 0. Okay, one thing you have to be careful about is before you factor, we have to start off with 0 on one side of our equation. Okay, next thing, square root principle. We're going to do this when we have just an x squared term. Okay, so for example here we have just an x squared term, so we're going to start solve for x squared, or solve for your squared term I should even say, which I'll explain that a little more when I get to this example. So first thing, I'm going to add 15 to both sides, so 3x squared equals 15. I'm going to divide both sides by 3, so x squared equals 5, and now that gives me my x squared by itself. So once you do that, you square root both sides. So if we take the square root of both sides, we're going to end up with x equals plus or minus 5. And remember, when we square root something, we have to think about both the positive and the negative value. Now for one like this, because we have x minus 2 squared, essentially we have just an x squared term. We can isolate something with just a square and have no x's on the other side. So that may even be a better way to think about it. We can solve such that we have no x's on one side and just a squared term. So right off the bat here, I'm just going to square root both sides. So that's going to leave me with x minus 2 equals plus or minus the square root of 6. And then I add 2 to both sides. So x, that should be a 6 here, x would equal 2 plus or minus the square root of 6. And we don't need to simplify it any more than that. If you want to plug it into your calculator, you're fine, but you don't need to. Okay, completing the square then, so a little bit of notes here. First thing we're going to need to do is isolate the variables on one side. So that means you're going to have both an x squared and an x term. And all your constants are going to be on the other side. After we do that, we add b over 2 squared to both sides. So remember that b comes from the value right in front of the x. So we're going to take that, divide it by 2, square it, add it to both sides. After we do that, it will be factorable. Okay, so we're going to use the square root property and solve. So after we do this, you can factor one side. Okay, the whole point of doing this is to create something that we can square root. So looking at an example of that, x squared minus 6x plus 4, I want to start by getting my x squared minus 6x alone. So I subtract 4 from both sides, and I'm going to leave a space right here. So I'm going to have negative 4 over here. Now this is the step where I need to do b over 2 squared. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9, which means I'm adding 9 to both sides. Okay, the reason I do that then, when I can factor this to x minus 3 squared. And that's going to have 5 on the other side. Okay, it's always going to end up factoring, and you might want to make a note here. When we add b over 2 squared to both sides, it's always going to factor to x plus b over 2 squared equals some constant. And now this is the point where I talk about doing the square root principle. So I'm going to square root both sides. That's going to leave me with x minus 3 equals plus or minus 5. Add 3 to both sides, and we have 3 plus or minus 5 as our solution. Okay. Another similar one, same idea, so let's change colors here. Same idea, we're going to add 1 to both sides, so we're going to have x squared plus 4x equals a positive 1. We take b over 2, so 4 divided by 2 is 2, square it, 4. So it's just coincidence we get the same thing there. And now remember, we're going to get x plus b over 2 squared, so x plus 2 squared, and that's going to equal again 5, again just a coincidence that we get 5. Do the square root principle, so we're square rooting both sides. We'll end up with x plus 2 equals plus or minus square root of 5. And then subtract 2 from both sides, so x equals negative 2 plus or minus the square root of 5. And that would be our solution for that one. Okay, so big thing here is that we're going to add b over 2 to both sides, and when we do that, that will allow us to factor to x plus b over 2 squared. Okay, this is an important piece. You're going to want to make sure you have that in your notes. So next one then is going to be the quadratic formula. So we have the quadratic formula. Okay, you've seen it a ton of times before. It's just a matter of plugging it in your calculator. As long as you do it in your calculator correctly, we shouldn't have any problems. Okay, the discriminant then is this piece of our quadratic formula, b squared minus 4ac. And the reason the discriminant is important is it tells us the nature of solutions. So if it is positive, we're going to have 2 real solutions. If it's equal to 0, we're going to have 1 solution, and if it's less than 0, we're going to have no real solutions. Okay, and we'll talk a little bit tomorrow about the importance of the discriminant again, but if we look at if it's equal to 0, or if it's greater than 0 and a perfect square, that tells us it's factorable. Okay, so that is one of the most useful things about the discriminant. If it's greater than 0 and a perfect square, it's factorable, or if it's 0, it's also factorable. Okay, so quadratic formula, I'm not going to do any examples for that because we've done it so much. One thing, we will review some of this stuff, but a big thing is there's a pretty easy way to type the quadratic formula into your calculator as a program, and it'll run. So if you don't have that yet, we'll talk about it in class. It's very easy to do. I'll make sure you get it on all your calculators, so make sure you bring your calculators to class tomorrow. And like I just briefly touched on, benefits of the discriminant, we'll talk about that as well, which will help us identify if quadratics are factorable or if they are prime. Okay, we'll see you next time in class.